My name is Kira, and today I'm going to be talking about Li curves. Here we see an Li curve for a laser. This was experimentally obtained. On the x-axis we have current, which is commonly denoted by the letter I, and the units are milliamps. And on the y-axis we have power, or light intensity, in milliwatts. We see this curve has a distinct shape whereby it increases slowly, reaches a turning point about 15 milliamps, and then begins to increase rapidly. The point at which the graph turns is called the threshold point, or the threshold current, and this is what defines when the laser is on or off. We see that prior to this point we do have some power output, but this is not a laser, and I'll talk about this in a minute. So before the threshold point we do not have a laser, where the laser is off, and after the threshold point the laser is on. This is due to two different types of emission. On the left we see spontaneous emission, which is what occurred before the threshold point, and on the right we see stimulated emission. Spontaneous emission is when a photon decays from a higher energy state to a lower energy state and releases a photon. There's nothing that triggers this, and there's no way to control it, hence it is spontaneous. On the right we see a similar diagram, but instead we have a photon, denoted by the blue squiggly line, hitting the atom and causing an electron to decay, releasing a photon. So one photon incident on the atom releases a second photon. These are related. They have the same phase and the same frequency and wavelength. So we use one photon to stimulate or to encourage the emission of a second photon, hence we have stimulated emission. Back to the graph, the Li curve we were talking about earlier. So you have I current on the x-axis, or the horizontal axis, and power, or light, on the y-axis. We see we have a threshold current. After the threshold current is exceeded, so if I, the current, is greater than this, we will have a laser, whereby stimulated emission occurs all of the time. Prior to this, we do not have stimulated emission, we only have spontaneous emission. There is no way to control this, and the light is random in a sense. There is no coherency between photons, and we have essentially an LED, where the light coming out is incoherent, and there's no connection between one photon and another photon. This is very important in characterizing a laser, as we want to know when do we have coherent emission or laser emission, and when do we have incoherent or essentially LED emission. Thank you for listening to my presentation, and I hope you enjoyed it.